So the first one here is retaining walls, and I'm gonna lead that one. Right here is one of our metal bin walls. All right, these metal bin walls are basically compartments, metal compartments that you fill. They're square, sort of. There's steel going in behind to retain the earth. Okay, what are the problems with these? Well, you can see the problems. In addition to the trees growing out of it and the grass, we don't really have a cutting program for that. But these things corrode from the backside forward. You can see here there's a big hole, here there's a big hole. These things are going to be a problem if you have them, and that's one of the questions I have, who has these? And by the time you realize there's a problem, you probably already start thinking about replacing them, because these things they go quick. So here's one photo. Here's another photo at the bottom right here. We have our inspectors have pokers, so they can, I don't ask them to hit it hard as they can and try to drive it through, but this was, as you can see, pretty easily pushed right through there. You got serious deterioration on the ribs. Our first attempt was this little My Little Pony Band-Aid that we tried to see it, and you see that didn't work. We just used pop rivets. I know Jeff's a big fan of these. We had a few discussions in the office whether this would even work. Well, we had a problem here, and you look, it continues to grow. All right, the water's in behind there, it's deteriorating it, and we've got problems. So we had to go on to plan B, what we've tried to do, and we put a bigger bandage on it. All right, this entire wall was deforming like you see here on these ones that we haven't got to yet. I believe we're welding to the vertical pieces, and this is a temporary fix. This is a 3 to 5 year fix, so we can get into our work plan and get this sucker replaced. This is not a small wall. It's, I'm going to say 15 to 20 feet high. I'm going to say over 20 feet since it's a railroad and they need their 22.5 clearance. So if that thing was to go, we got a big problem going on. And here's the total fix that was put into that. This is kind of caveman engineering. We got a problem, we're going to cover it up and close our eyes for a few years, and hopefully it works. First question I have, who has these type of walls? With these, have you seen this type of distress?
We have, and we've recently had about 3 or 4 projects to replace these. And we've approached it from a couple of different ways. The first project that we had, we decided, first of all, we did an investigation and found that the rear side of these bin walls had asbestos coating, which is an environmental hazard, and we had to be very careful in how we removed those walls. What we decided to do was to leave the wall in place and to puncture it and use soil anchors to drill at an angle and anchor the wall using precast concrete panels to anchor those walls through with the soil nails. Another approach that we used, we had some room, so we put some temporary earth retaining system behind it and replaced the bin wall with some T-walls. And so those are the 2 types of solutions we've had so far.
Oh, we're going to go to New Hampshire.
I'll probably have to ask Steve to help me on this, but anyway, we've replaced them obviously with wooden or other types of retaining walls, but recently we were asked to look at one it's fairly tall, similar to this. We determined that the columns were still in good shape, and we talked about just replacing the panels themselves with new panels. We also talked about putting studs on the columns if they're still good, and facing the whole thing with concrete.
Nova Scotia,
Yeah, so we had pretty much the same sort of problems that you guys were talking about, but one other item that we had was, it was a corner of a bin, and the bottom, at the very bottom, is probably as high or higher than the one you show on the picture, and the corner was actually starting to deform and as if it was bending out of plane and starting to tip over. So some of the options that we've looked at are just what has already been talked about previously, but we haven't actually implemented a permanent fix for the structure yet.
Right.
But one consideration, we have a railway, while it's an abandoned railway that's now a recreational trail, we've considered just doing a tunnel liner and then just abandoning the wall completely. Now, obviously, you wouldn't be able to do it in this case here.
Vermont?
I mean, we have them. I personally haven't been involved in any projects to replace them, but I think in the past we've just replaced the panels with wood.
I was wondering, Doug, if when you're going to face it, are you going to have to put a toe on it as well for overturning?
I have a report that shows a number of fixes on it. Remember me showing that to you, Ben, or not? But
I do.
Maybe we can put that someplace so the group can see it if they want to try to abate this. I mean, it has a different types of fixes. Some are sheet piles. Some of them are the soil nail with the concrete face on them. But it lists and shows different pictures of different type fixes. So I guess I'm kind of asking Ben, where can we put that on the website?
Ed, can we either attach it to this presentation or put that on the website?
I'll follow through with it. I'll try to get it there somehow.
That means, hey, Ben, what do I need to do to make this work?
Dennis Tang or to me, we'll get it into the blog. I'll give you a card.
Okay,
Excellent.
great.
Not related to a fix, but I'm just wondering, has anyone ever taken these out of service and seen what it looks like in behind? Like the face is all rusted out, but is the bin in behind in good shape, or is it rusted out as well?
New Hampshire?
Like I said before, the one that we're looking at currently, they did do that on the tops. You can kind of get into the backside and see if you pull out enough fill. The ones we have are filled with stone, so.
I was just wondering, is it the corrosiveness of the soils behind the wall that you attribute this deterioration, or is it just water getting to the steel?
I think it's water. I mean, it's wet back there. There's no place for it to dry off. It's just constantly on there.
Well, I was just going to say, though, we have a multi-cell pipe that's 25 feet. They're just a series of arches that were made out of corrugated metal galvanized. And in the last, I guess it's been out there 25 years or so, or 20 years, half of the pipes are completely rusted through, like what you're showing there, where there's significant deterioration. The other half looks perfect, just like the day it was put in. But it's the result of the soil that was behind it.
Oh, so there's corrosive soil.
Yeah, we had corrosive soil. I just wondered if you guys looked at that. Is that possibility? Because putting in steel with a corrosive soil is not going to help you in even
I think it's a possibility, but in theory, that would have been a gravel borrow that's been tested that could drain out. So I'm not saying that Jeff, who put these in the 70s and 80s.
Right. I think what it is how they're constructed. You know, it's galvanized material, and, you know, you're going to dump your material against the wall, and it's going to be a violent, compacted type action. So what you've done is you've created holidays in the back of your wall, and that's what you see, is it rusts from the back to the front. By the time that you see you have a problem, it's too late. You know, as soon as you see that first little freckle, you're going to be able to poke your finger through it, most likely, right? So other than having to fix these, the next logical step, or the first logical step we did was, we don't use them anymore. We put a moratorium on them.
You know how I like to disagree with John, so. I think John is right, but if you look at this picture, notice where the panels are. They all stop at the same elevation. So we think there is a soil issue there. Whether the bottom is just common borrow and the top is gravel, we don't know because we haven't taken it apart. But if they all stop at that same elevation on both sides, well, this is a different wall, Ben, so I don't know what this one's got.
Oh, okay.
I was just looking for a place to disagree with John, that's all.
It's probably the environment it's in, you know, the soil as well. I won't disagree with that. It's going to have an impact. But we have other walls that you'll find the deterioration randomly from top to the bottom. You know, I think it's just a matter of where stones and where it got violated and all that, you know, just like anything else.
These have been out there, these have been out there 35, 40 years or so. It's about the 80s, 70s and 80s when these were placed.
Has anybody considered gunite or any form of that with some sort of anchors? You know, I would imagine that might be simpler than forming the whole thing like Doug's going to plan on doing.
I believe that option is in one of the pamphlet that Jeff has that we're going to send out.
Connecticut considered gun-niting or shotcreting these, but you have to remember how these were designed originally too. They're a bin. They're stacked. They have walls that go perpendicular to the face of it, and if those are corroded as well, you're losing connection to the soil. So you may fix the face, but then you may lose the entire face all at once. So that's a temporary fix, and you may buy a few years to get a project out, but you may see your face moving in that time. So just keep that in mind. It's probably a temporary fix.
For
Anybody
bin
had
walls.
any kind of failure on these, close the roadway? I don't think we're there yet in time, right? I think we're on it, we've recognized it, but not that I know of. Has anybody had that kind of failure?
On Route 8 in Waterbury, Connecticut, we came very close. We had some serious impending failures on a roadway on a wall carrying Route 8. We addressed that through a project in a timely way, so we wouldn't lose that, but we came very close.
Okay, now we're going on to MSE walls. And Jen Hawkins got me these pictures from New York. We're having a similar situation on a local bridge, and the town just kind of says, yeah, whatever, so. All right, here's an MSE wall. There's precast panels. You've got reinforcing either straps, a geosynthetic grid, or a steel grid, something back anchoring it. There are several different types of systems, different shapes of these. You can see here there's some drainage through the wall. There's some leakage there. Okay, here's the situation that they've had. This is, to answer Jeff's problem, yeah, this is the first one I've seen on this. Moving forward, you can see the straps kind of dangling there, spaghetti. That's a different wall.
This is a different wall, but they were all built in the late 70s under the same project. So once we had that catastrophic failure on the other wall, they went back and looked at this one that was bulging, had been bulging for a while, and said, you know what, maybe we should do something with this one. So, yeah.
Excellent. There's another situation there. Here, in top view, you can see the straps. Looks like they've been deteriorated. Concerns that I have with these walls is you can't see what's going on, like the metal bin walls. When it starts to go, because it might go quick. It could either be the connection to the wall, or looks like here there was a deterioration of the actual straps. Oh, here's the main one. A few panels have actually falling off onto the railroad area. It's starting to undermine our abutment. You see here is a little bit different reinforcing system. Rather than straps, we have a grid going back. That's not standard. That's just what was done here. Okay, this is New York's, one of their fixes. You know, you just can't fix a few. You've got to pull it back, so it's a bigger operation than you might think. Just can't remove and replace or mill and fill like you can a wearing surface. All right, here it looks as though they did a anchoring system, some soil nail type system to reinforce it, and they kept most of the wall. Okay, that's the last one I've got. I'm sure most of you have these type of walls. Let's start the discussion now with any concerns or issues you have. We'll start with Jen here, please.
Something for this The interesting thing about this one is the MSC wall was on the other side of the ramp as well. This was a ramp down near New York City, the Sawmill River Parkway. And the straps actually overlapped from each wall from each side of the ramp. So they had to take the whole ramp, the whole wall on either side to do a grass wall. So that was this one. The other one that they caught early enough was they were able to soil nail it. Yeah.
Was any forensic investigation done to determine the cause of that crack? Typically, in the pictures I saw a lot of water coming through the wall. Was drainage looked at as a possible source of that?
Yeah, they did look at the drainage. There was a basin there, but I think they realized that the water wasn't really reaching the basin. Everything had settled around it, but never really got in. So they think that's kind of what happened. That drainage just, it sat there, and that was that. Yeah, just kind of leaked out.
The second thought I had was after you mentioned that the straps are overlapping, I believe the code addresses that, the design code, about how close those walls can be to each other. So I don't know if anybody looked into that. We recently constructed some MSC walls for a multi-use path that was fairly tall, and we deliberately separated the walls by enough distance to make sure that each set of straps was doing its job properly. So that's another thing to consider. Just make sure you're following the code for the overlap.
Yeah, we had a situation where a car went off the road. It was outside the clear zone. The car launched up and hit the wall and pushed the panels in about 1.5 inches, 3 panels. Unfortunately, it was a fatality, but it also took and pointed out that these things are vulnerable if they're not protected. And this particular bridge, it's holding up the superstructure over the interstate. This was one of the things we said, okay, now we'll call the manufacturer, we'll find out what the repair method is on these that we've always been wondering about, and figuring that we had some great process in place where you could take and freeze the soil behind or something of that nature. And what they came up with is, oh, you should just take and cast a patch over the outside of it, overfill essentially around the areas and tie into the panels around it. I was okay with that, but Doug wouldn't let me cast a concrete that looked like 2 Band-Aids going over the top of it. I guess I would be cautious about using these to support the abutments itself unless you've got them protected.
Yeah, we had a similar situation in New Jersey that just happened, and I just happened to see the report on it, and the forensic analysis was that there's a dissimilar metal, basically the hook that the strap tied into was a dissimilar metal, and it corroded there and released. I think MSC's corrected that a while back, but these were earlier versions. So I'll see if I can get that report to the folks here at the partnership so that everybody can see it.
I think Steve mentioned the abutments, not to use these for abutments. Connecticut has been experimenting, or more than experimenting, we've been actually building MSE-type abutments using a technology called GRS-IBS, Geosynthetic Reinforced Soil Integrated Bridge Systems. And we've been very happy with it. We're considering that on many of our bridge abutments now instead of concrete abutments. They're easily built. They act on the same principle as the MSC walls, but the fill is an open graded stone that's free draining. It's compacted in 6-inch layers with geosynthetic soil reinforcements. It goes in very quickly. As I said, it's free draining, so you don't have any concern about moisture, water building up, pressure building up. It has a block facing, or it could have precast panel facings. But we're very encouraged by this technology. If anybody wants to do this, Connecticut has some experience with this, and Dan Alzamora from Federal Highway Administration was very instrumental in leading us into this technology.
My issue, and Steve, just like you guys had, it was on the Capitol Beltway. Someone ran into the abutment face, and it was carrying the Capitol Beltway, and destroyed like 6 or 7 panels, and then we did the patch, the concrete patch, but it was underneath, so it didn't make that much of a difference visibly. But my question is going to be is, and I've never posed this, but to the manufacturer, when these panels start deteriorating, like, you know, you build a retaining wall out of a cast-in-place concrete cantilever retaining wall, it deteriorates over time. I mean, if it's getting exposed to salt spray or whatever, there's no treatment on these. And if they start deteriorating, that's your face. Are they talking about that you would go and individually replace them over time? Similar to, you know, the metal panels, if these start deteriorating to the point where the straps are free because the front face is gone, that means you're going to do like a hodgepodge of replacing these. I mean, I know in Maryland they've been building them, but we've never been a fan of them.
Yeah,
Just to point out, as a follow-up to that, on the GRS IBS type abutments, and we also make wing walls and other walls out of them as well. The block facing or precast facing is just that, a facing. So if it were damaged, it could be replaced without affecting the structure. So it's actually safer than the wall facing being a part of that structure. So that's why we like that technology. For new structures, anyway.
as far as the panel facing, I'm not quite sure yet what's going to happen. So it may have to be fix similar to that, or you possibly put something in front, and I'm not sure yet. I'm gonna let the capital program figure it out and then complain if I don't like it. So your question is anybody preserving them, putting
spraying them with some sort of coating to prevent them from deteriorating? I mean, over time, we all know that, you know.
Yeah, not yet in Maine, but it sounds like a good idea. Is anybody out
ideas?
there treating theirs? New Hampshire is, New York? Not, you don't
What are they
know?
using?
No, I think it's a real good idea, just haven't done it yet. I got a question to the group. In Maine, we put a membrane over the top to prevent a lot of water / chlorides from getting down to those steel straps. I believe the steel straps are galvanized, but over X many years, it's going to wear down. Does anybody else do a membrane over the top to try to save them from the chlorides? New Hampshire does. No, other ones aren't sure. How about T-walls? I'm sure we all pretty much have T-walls or some type of concrete, whether the stem's going back or there's now a double wall where there's concrete cells that you put on top of each other's blocks that you fill. Has anybody had any issues with those?
I guess about 8 or 9 years ago, we had a stream that was running not close to the wall, and it was the box, you know, concrete box filled with stone, again, the Capitol Beltway. The stream digressed and went up against the face of the wall and undermined the footing, which was only like, you know, a 2-foot footing, and sequentially all of them collapsed into the stream, and we had to go with a Geiken system where basically it runs like a train on top of the sheet that it pushes into the ground, and because it was about, I don't know, 150, 200 feet of this wall had to be replaced, and it was in a non-accessible area we couldn't take the Beltway. It was like,
Right.
I think 6 lanes at that location, and we couldn't do anything. We had no shoulder to work from, so that's the way we would rectify that.
So it sounds like scour of the wall. Does anybody know their requirements, or do you allow these type of systems, wall-type systems, near waterways? I know we don't allow it. If there's any flow at all in a ponded situation, we make you get down there quite a ways before you can start your wall. Does anybody else have those type of requirements?
All I said is I'm pretty sure that we do, but I don't know that for a fact.
How about those panels? I know they're precast, but is there any chloride inhibitors? Do you require that on that to try to preserve it from the initial design?
One of the things Connecticut has been looking into is some additives for our concrete, including some precast concrete. And we haven't had this discussion with those manufacturers yet, since they're proprietary products, but in structures such as box culverts and other precast elements, we've been trying an additive called Hycrete in the concrete, which prevents chloride and moisture intrusion. As far as we can tell, it's a very successful admixture. It seems to create a rubber-like substance that kind of fills the pores in the concrete and prevents intrusion of moisture and chlorides into it. And it has an added benefit of coating rebar as well. If the moisture gets to the rebar, it'll form that protective coating over the rebar and prevent the corrosion of the rebar as well. So we're looking to expand the use of that. We're also looking into other technologies as well, but that's one thing that we're talking about doing.
I guess, Ben, I'd like to ask, does anybody have any other types of walls? I'll just see if you can top this. We have wooden walls, which I imagine all of you have, but we also have a string wall. It's string. I think it was a ledge face or some type of loose rock, and they've got a string on it. So I can tell you when I drive by it, and it's near my home, I just put my hand up and go by, because I haven't got a clue how to fix a string wall unless anybody else has that. But Ben, I think for your conversation, it's on Route 4. It's on, Kitty did it, it's on Route 4. I think we should prolong this discussion for more meetings. I think this is a good topic, because I think these are just coming to fruition where we have some issues.
It's not a string wall, number one, my friend. If you would have asked me before, you could have spoken a little more eloquently to the subject. What it is, it's a stabilized slope, right? Rock face, you know, you drill and put the anchors in and all that, and then they put string, in other words, right? Just to capture any of the loose rock, that's all. It's not really a structural thing, it's just like a little net to capture loose stuff.
Okay, so it sounds like a net so the rocks don't drop on people's heads.
But yeah, no. Well, it's a pretty common, you know, where you get a lot of fractured ledge and things like that. You know, you can stabilize it in mass, but the small pieces, you know, you can't, right? So what you do is you just try to capture them.
Actually, Ben, I think this is a fantastic topic, and we're just sharing it with a quarter of the country. If we could do this, if you'd be willing to do this at the national meeting with all 4 partnerships, I think that'd really be of great interest and great assistance.
Yeah, I can do that.
John, we just did put out the call for papers on this, or call for
Coming out.
topics? I mean, I would think that some of the other partnerships would be willing to sacrifice a few, you know, horror stories that if they've had them, which I think they probably have. So I think it would be a great topic.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.